So, so now we'll try to implement this clipper circuit. So we'll try to implement this clipper circuit in LTSpice and see. So what you are asked for is you are asked for to find out the V in and V out. So basically, whenever you are applying a V in of 16 volt peak to peak, what is your output? Provided you are giving this 3 volts, so it is supposed to clip at 3.6 or 7 volt, depending upon what is the cut-in voltage. And then of course you also need to plot the V out versus V in, the voltage transfer characteristics. So to do that in the LTSpice, you can draw this circuit. So you can get your component, you can get the diode. I'll go a little fast because you already know these stuffs. So diode is here, and get your resistor, rotate it. So now we have this 3 volt. So sorry, the diode is connected in this direction. So you can just need to rotate it again. Move. So to connect duplicate. So where them? Ground it. So as I mentioned, you are supposed to take this as based on the manual 1K, and this is of course you need to go to advanced and you need to go for a sine wave generator. So get the sine wave generator. The C offset will be 0. The amplitude you need to take it as 6. This is 16 volt peak to peak, right? So that's why the amplitude will be only 8. So you should be very careful. So the quantity that you have to plug in here is 8 volt. That is the amplitude. But in the manual it is told that V in should be 16 volt peak to peak. So this is the peak to peak voltage, not the amplitude. So you need to make the amplitude 8 volt. Frequency you're asked for is 1 kilohertz, so 1K. So I think these are only the information that you're supposed to provide for this voltage source, 1K. And again for the diode, again pick the diode that we have mentioned in the manual. This is 1N4148, right? 1N4148. So this is the diode that we'll be using. So now what we have to observe is to observe the potential at this with respect to ground. So now you can do a transient simulation. So for transient simulation, again go to edit spice directive. Either you can directly type it here as .trnn. So because this is 1K, so one cycle is of 1 millisecond. So if I want to see 3 cycles of this sine wave or 3 periods, I should write 3 milliseconds. So this is just the usual transient simulation that you also have done before. Now do the simulation, and you can observe the voltage here and also the voltage here. So the input and the output. So I think better let me name this as input and output so that it becomes easier to identify. So you can type it as V in here. So this is my input with respect to ground, and net name V out, VOUT. So you can just name the net, and then you can do the resimulation, and you can plot the V in. Just get the plotting. So you can see here, right? So you can see here the peak to peak voltage of the input B in, which is this green one, is from 16 volt, right? From here 8 and 8, so it's minus 8 to minus 8, so it's 16 volt peak to peak. And you can see that, as I have mentioned, like as soon as this voltage becomes higher than the 3, I think, oh, we have not mentioned this voltage, we should mention as 3 volt, sorry, 3, and then so again we simulate it, sorry, there was a mistake. So as soon as we make this like that, you can see here this value is around 3.65, because the cut-in voltage is around 0.64. So as long as as soon as this voltage becomes this 3 volt plus this cut-in voltage, the diode starts conducting, and it's a short circuit. That's why this whole voltage will be appearing here. So you can see that the voltage waveform is clipped. So if I vary this voltage, maybe let's make it 4 volt, right? Then you can see here, if I again do the resimulation, you can see here it has gone to 4.64, right? So 4 plus the triode drop-in voltage. Is it clear? Hello? No doubt, right? Till this point is clear, right?
Yes, sir.
Okay. So whenever you'll go for this kind of, so you'll get clipping in both the direction. So depending upon what voltage that you give here, the clipping will happen at that place. So that's why you're supposed to do for the part B, like that. So now we want to get the voltage transfer characteristics, VTC. So for the voltage transfer characteristics, what we are supposed to do is, now if I slowly vary this input in VDC, what will be my output? So basically, it's slowly varying this input, maybe from negative voltage, say from minus 8 to 8 voltage. So I'm slowly increasing the DC. Then how will be my output look? So it's the V in versus V out curve, like that. So to do that, again, let me go back to my 3 volt scenario, and of course here we need to change this type of source. We have to go for DC source. So you can go back to DC source, DC, because here we want to slowly increase the DC value. So we just want to plot the V in versus V out characteristics. So if I am slowly increasing my input voltage, how will my output voltage look? So that's why we need to go for we need to change it, this one. So and now I need to even delete the transient simulation, because I am not supposed to go for transient simulation. I'll be going for DC sweep analysis. So for DC sweep analysis, you can just again go to graph spice directive. So again, because I'm using a Mac version, so I have to always right click, and I don't have a shortcut available here. So but in Windows version there are shortcuts available at the top, so you can use that also. So again, operating point analysis. So here you need to go for the DC sweep. Again, I'm recording this this demo, so you can anytime again go back. I'll be uploading it after the class, so you can go back and you can always see. So basically, what I will be doing here now is I'll be sweeping this voltage, which is basically V1. I hope it's V1. So just like no. So I'll be just sweeping this voltage V1 from, again, as I have mentioned, from minus 8 volt to 8 volt. So this V1 I'll be sweeping linearly. So I'll be sweeping, my initial voltage will be 8 volt, final will be 8, and maybe let's sweep by just 0.5 volt. Okay. So that is my I'm doing a simple DC sweep. So basically I'm sweeping this V1 voltage, right? So from minus 8 to 8 volt, and by a step size of 0.5. So if I then now plot again, right? If I plot again, right, do the simulation, and again plot the V in and V out. So of course here I don't need to plot the V in. You can just delete this one, V in, because V in is already plotted here. So you can see here, like if I little bit so if I so the x-axis here is my, this x-axis here is my, sorry, the x-axis here is my V in, so where I am varying it from -8 to -8 to, I think there's some issue. Let's go again. Full screen. So where it's going from -8 to 8 volt, and you can see the out is getting clipped at I should say this voltage is around 3.64 volt, like that. So it's getting clipped. So this is my input output characteristics. So which you are supposed to do for both the circuit. For the other circuit, you'll get a clipping here depending upon wherever you're keeping that other voltage. So you'll get a clipping here, like that. So is it clear?
Yes, sir.